This video is the second half of the video, or the video sequence that talks about AM modulation and demodulation. If you've not seen part one of this video, you should watch that first. In part one of the video, we basically got to the point that we have on the screen where we have this mess. Basically, what we have here is we developed what the spectrum of the AM modulated signal would look like. And this is a signal that gets broadcast. Now, the idea in the demodulator is we want to, we actually want to look at the radio receiver and figure out how this radio receiver is going to take the signal that we want, which is this one, and separate it from all the other signals that we don't want, these nasty green and brown and orange signals. These are from signals, or these are signals from stations that we don't want to listen to. And so basically what we need to do then is figure out how the AM radio does this. Well, I've actually drawn a picture here that shows, at least conceptually, how the AM radio does this. The antenna of the AM radio is hooked into what's called an RF amplifier. This is an amplifier that's actually also a bandpass filter. We then have a mixer and another bandpass filter and then a demodulator. And what we'll do is go through each of these steps and look at what's happening in this system in the frequency domain. So let's first look at the frequency domain representation of what's coming in from the antenna. And to do this, we'll get an empty page. Again, coming in from the antenna, so this is at point A in the system. In the frequency domain, I have something that looks like this. I have out here at omega c the information that I want, and also at minus omega c. But I also have all of these signals from all the other radio stations that are broadcasting and that my antenna picks up. So I've got lots of stuff here, and the issue is that I don't want to listen to all this other stuff. I want to listen to the one station that I'm tuned into, the one that's at omega c. And so that brings us to the next step. If we go back to our diagram of the demodulator, or the radio, I have what I call an RF amplifier. The RF amplifier takes the signals coming in from the antenna, which sometimes are very small, can be millivolts or less, and amplifies them, and then also it's a tunable band pass filter. Okay, and so what this RF amplifier is going to do is start to get rid of the stations that I don't want to have. So if I go back to my other window, we'll draw the frequency response of this tunable bandpass filter. We'll draw it in blue because it's a nice useful thing. Now it turns out that this tunable bandpass filter is not a very good bandpass filter. And the reason for that, this again is the magnitude spectrum of the, magnitude spectrum of the frequency response of the tunable bandpass filter. And you can see that the pass bands, or the pass band, is at omega c, and as you get farther and farther away from omega c, that the frequency response gets smaller and smaller. So it does get rid of frequencies that are not at omega c, but it doesn't do it very effectively. Again, the reason for this is that this is tunable.